this video, we're going to look at two more problem-solving strategies. The first one is examining a simpler case. So what we're given is the length of each side of the triangles shown below is 1 inch. So it's really an equilateral triangle. So each side is 1 inch. So if we have that 100 triangles are placed as shown, what is the perimeter of the figure that's formed? So we see something that says simpler case. The reason why we'd want to even consider that is because look at what it's saying, 100 of these triangles. That sounds like a lot. So we start with kind of like baby steps. So if I just look at one triangle, so let's look at the number of triangles. If there's just the one first triangle, let's consider its perimeter. So remember, perimeter is the distance, that's what this part of the word comes from, the distance, and peri means around. So we want to look at the distance around, and again, just looking at one triangle. So we have 1 inch, 1 inch, 1 inch. That's going to be a total of 3 inches. Now when we look at two triangles, now we're putting these pictures together where there's going to be two of them. Now we have 1 inch here, 1 inch here, 1 inch here, 1 inch here. We don't count that guy because that guy is inside. So what we will have then is that the perimeter for those would be 4. So then we're going to look at if there are 3 triangles. So if there's 3 triangles, again, kind of extending the picture. And this is much simpler than thinking about 100 at first. That's why this is a good strategy to use when you have like something with bigger numbers like that. So if we want to measure all the way around there, now we're going to have one side as 1 inches, 1 inch. Well, there's 1 inch here, 1 inch here, and 1 inch here. So there's going to be a total of 5 inches. So our perimeter is 5. Now at this point, you might be saying, oh, look, if we have 1, then we go to 2, then we go to 3. When we look at the 4th triangle, let's see what's happening with the perimeter. We were at 3, then we added 1, and what do you think is going to happen? Well, looking at that pattern, which is another one of our strategies, it looks like it's going to be a 6. So let's see if we're right. So we're now extending that, and you can see why it's going to be one more. This piece basically gets moved over to now be that side, so that's the same perimeter, but we add on this new guy right here, so it's really increasing by 1. Now the other thing that you might be noticing is that when we have one triangle, the perimeter's 3, which is a difference of 2. And a difference of 2 here, and 2, and 2. So if we're asked to go all the way down to have 100 triangles, if we notice that pattern, we could say, oh, well, plus 2, that would be 102. Or you could continue this counting pattern and see what happens and how it is off by just 1 every time. So now we know that there would be a perimeter of 102 by looking at the pattern. And that would be 102, make sure we put our units in there, inches. And we could even generalize this, similar to how we have done before with Gauss's problem, but to generalize this, if you had the number of triangles being n, then we could say that the perimeter for this particular setup can be written as n plus 2 inches. That would be our perimeter. Okay, we're going to move on to number 4. And the strategy that we're going to see here is identifying a subgoal. And we're also going to try and make the table again, kind of putting those two together. So it wants us to arrange the numbers 1 through 9 in the squares below so that every row, column, and major diagonal is the same. So we have to have that every row, column, and major diagonal is the same. And this would make a magic square. That's what this thing is called. And so when we say it's the same, I guess I left out a word here, it's going to be the same sum. So let's think about what we have here. the sum of the 9 numbers, which we have to put in here, well, like 1 plus 2 plus 3 plus 4 all the way to 9. Well, we can add those together pretty quickly, but we can also use Gauss's idea. What was Gauss's idea again? We could take 9 plus 1 and we have 9 of those divided by 2. So this is going to be 90 divided by 2. So we have 45 is our total of all the digits in there. So if you think about what we're trying to do right now, again, this is like kind of our sub goal, is to figure out, well, what does this sum have to be? And if you notice that if we look at these 3, I could look at rows or columns, either way, but I have that this sum is the same as this sum, which is the same as this sum, and all together, this has to be 45, so they have to be the same sums. So really I could take the 45 and divide by 3, and I know that 15 is that fixed sum of every row, column, and diagonal. So that was kind of like our sub goal. We want to find out what that sum has to be. So then the next thing that we want to do is find out, well, using those digits 1 through 9, like how many of them are there in each of the different sums. So like if I want to make the total of 15, let's think about what 3 numbers between 1 and 9 make 15. So we know that 15 is like 1 plus, well, if we have 1 in there, what else do we have to have in there? We would have to have a 9 in order to make it get big enough. So 1 plus 9 plus 5. Or maybe we could have 1 plus, well, if this was 8, then this we get up to 6. So then let's kind of try again. So if we want to have 1 again, well, what would that need to be? That would be 1, and that would be 7, which would be 8. But then I can't increase that because I already used the 7. So then I can't find another sum. So what that means then is that the number 1 is only in 2 spots, or in 2 of the sums. So then like next I would want to look at what about the number 2? So if I put 2 and 9 together, so that's going to be 11, I'd have to need 4 more to make 15. So let's try that again with the next smaller one. So if I have like 2 and 8, that's 10, and so then I could put 5 in there. And if I take 2 and let's change that one to 7, and then that one to 6. And there's other strategies that you could use to find the total for this magic square. This is just one way to do it. So feel free to try it on your own and come up with some other ways. Let's try it again. So if I put 2 with 6, well then that would have to be 7, but that's really that same sum, so that's not something different. So we don't want to include that guy. So you can see right now, again, that, not again, but the 2 is in 3 of the different sums. So we could kind of keep going through this process to try and figure it out. I'm going to make a table to organize my information. So I'm going to write the number that we're talking about. So in particular, we did it for 1 and we did it for 2. We could do it for all of them, 3, 4, 5, 6, 7, 8, 9. And we want to know the number of sums that contain that number. So like the number 1 was only in 2 of the sums. The number 2 was in 3 of the sums. So what we really want to do is find out all the other sums that could exist to make 15. So let's look at a couple more here. Let's see, let's up it to 3 and see if we can find them all. So 3 would have to go with, if it goes with 9, well, that would be 12. That would need another 3, so that doesn't work. So I'm going to erase that. How about if I put 3 with 8? That would be 11. which would be able to combine with 4. What if I put 3 with 7, that's 10, then we would need a 5, so that works out. And we could try another one. 3 with 6, that would be 9, but then we'd need another 6, so that one doesn't work. So that means that the number 3 is in 2 sums, so we can fill that out in our little table here. So then the number 4, well, we already have a few things with the number 4, so we want to make sure that we don't repeat any of those guys. But let's try and write down those ones next. I'm going to fill this in right here. So we're going to have 4 plus, again, we could try it with 9. That's 13, and then we get 2, but that sum was already kind of written down up here, so I'm not going to write that one down again. I'm going to erase that, and we need to find a new sum that hasn't been used yet. So let's see, I already see the 4 in there, so make sure I don't forget to count him. So what about if I put 4 plus 8? Well, we already did that one over here. 4 plus 7 hasn't been done yet, so let's stick the 7 here. So we have 4 plus 7, that's 11. Then we need 4 again, so that one doesn't work. So how about, let's try, so we tried 7, how about 6? So if we have 4 and 6, that one would have to go with a 5, so that's 15. So that's a new one. So we actually have 3 different ways that we could write the number 4. Or the sum with including a 4. So then we want all the sums that include 5. So if we look at that, so far we have 1, 2, 3, 4 different ways to write the number 5. And so you could think about if there's any other ways to write the sum that would include the 5. And there's actually not going to be any other ones. To do 6, I have 1, 2, 3 that include the 6, and that's again going to be all of them. I think I've listed all the possibilities by now. So we're going to write that there's 3 ways to do that guy. And then the number 7 is going to be happening 1, 2 times. So we'll fill that in. And the number 8 is happening 3 times. So we'll fill that in. And last, the number 9, we have that only happening twice. So again, the reason in doing these little sums here is so that we can see which number is going to be needed in each spot. So if you go back to where we were, we wanted to fill in this square here with the numbers 1 through 9. So you can see that the number 5 is in 4 different sums. The only way that could happen is if 5 was in the diagonal, because then it will be in that sum, that sum, that sum, and that sum. That's all 4 of them. So then what's next? Well, we have 4 numbers that have to be in 3 of the corners. And the reason, again, that I know that has to be in the corner, well, let's look. This 2, 3, if I stick 2 in here, it's going to be in a row, a column, and a diagonal. So it's going to be in 3 of those sums. So I'm going to put the 2 in there. And then if I put, let's think about what sum 2 needs to go with. Well, it's going to be in a 4. We could put a 4 in here. And then I'm going to fill in, because that happened 3 times. We need a 6. Oops, not 6. Undo. We're going to have an 8 in here because 2 plus 5 plus 8 is going to be the 15 that we need. And then if we, the other number that we need to put has to be a 6, which, just double checking in here, that's going to be 9 plus 6, that's 15. So we got our 4 corners filled in. And now the middles, those are only happening twice. So really we could just finish off by seeing what number is missing. So for the first column, 2 plus 6 is 8. So we'll need a 7 to make 15. 4 plus 8 is 12. So we'll need a 3. And again, just double check. So this new row that was completed also adds to 15 as needed. Let's see. In this column, well actually row, 2 plus 4 is 6, so we'll need a 9 in there. And if we have 9 and 5 in that column, that's 14, then we'll have a 1. So just double checking that I included every guy. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is one strategy for kind of working through it, and it kind of has a system. The big thing we needed to do was find all the sums possible that can make 15 and then work from there. So you get a chance to try this in your homework.